So now that we've studied methods, let's improve our cell phone contract program. This is our 6th, and I promise our final iteration. So to remind you of the problem, suppose you want to compare the cost of several cell phone plans with ATV telecommunications. Each plan has the same basic design. A flat charge gives a fixed quota of minutes a month. Additional minutes are charged individually above the quota. We're going to write a program that compares a user-selected number of plans. Now, the main shortcoming of our previous work is that our main program has gotten too long and complicated. Let me explain why this is a problem worth fixing. Once a program gets long, it's what we call spaghetti code. The reason we call it that is it's like trying to trace through a strand of spaghetti in a plate of pasta. It's really hard to follow. Once you've created code that's like that, simplifying it with methods is one of the ways of improving it. We also want to create chunks of code that can be reused instead of having to build everything from scratch every time. So that's another reason for fixing this problem. As it is right now, our code is pretty much impossible to reuse. Let's examine the code. Now what we're looking for is segments of code that do a well-defined tasks and methods that can return only one thing. Now this turns out to be a big limitation. A lot of things we'd like to do with methods can't be done because we'd need to return more than one thing. When we're looking at our code, let's think, for example, about do negative numbers make any sense for this data? And does allowing only one mistake make sense? Because that might lead us to some good methods. Now I copied our code in from iteration 5, so we have that to work from. So looking through the code starting at the top, we see, for example, that we have a bunch of code here, right in this area of the program, that does a well-defined task. So we have the variable talk minutes, we prompt the user for what we want, and then we allow them to enter it repeatedly. Now in this case, we're only letting them enter the data twice. That's a limitation we don't need to have. So this is a place where we might be able to put a method. Now the question is, are there other places where we could reuse it? Well, as we go down, what we'll see is that we're entering things like the monthly cost, the plan minutes, the additional minute cost. None of these values should be negative either, and so it makes sense to use a method for that. Before we write a method, we always design the signature for the method. That is the header for the method. So we consider the inputs. Those will be the parameters. In this case, the input would be a scanner that we could call something like keyboard. We'd also want to consider the method name. So a good method name might be getPositiveInput. Methods, remember, are verbs, and so they usually start with a verb, like get. Output is the return type. So in this case, well, some of the variables we wanted to get were doubles and some were ints. It turns out that we can't have a method signature that sometimes returns a double and sometimes returns an int. It has to return one or the other. So we're going to have to reconsider our method name. Maybe instead of getPositiveInput, we could have one method called getPositiveInt and another method called getPositiveDouble. The rest of the signature is now correct. Now all of these methods are going to be public and static, at least for now. This is another one of those magical incantations that we'll understand in a few weeks, but for now we just have to remember to say it. Let's go and create the methods with the following signatures: public, static, double, getPositiveDouble, scanner keyboard, and public, static, int, getPositiveInt, scanner keyboard. One thing to notice before we get started is we have parallel construction here. So notice that the parameters are in the same order. Now in this case there's only one parameter, so the order doesn't really matter. The names are the same. So get and then positive and then int or double. The capitalization is the same. Everything is exactly the same. That makes it easier for other people to use our methods when we have that type of parallel construction. One other thing we might think about when we're getting ready to create this method is, do we really want positive data or do we want non-negative data? Now that's a subtle difference. Positive means numbers that are bigger than 0, and non-negative means numbers that are greater than or equal to 0. So the question is whether 0 is valid data or not. For all of the things we're looking at, 0 doesn't make sense as data. And so we actually do want positive. This is an example of testing a boundary condition before we ever start writing code. So here we are in Eclipse. Now you can put your new methods anywhere you want. You can put them above the main program or below the main program. I like to have the main program up at the start. So I'm going to put mine below. So this is the end of the main program. And I'm adding a comment in so that I know that that's where the end of the main program is. Here are our methods: public static int, get positive int, scanner. We can call the scanner anything we want, remember. It does not have to match the argument name. Now, until we write these methods, I'm just going to put in a stub. So I'm just going to return 0 for now. We'll fix that when we actually write the body of the method. In public static double, get positive double with a scanner input parameter. So here we'll return 0.0. And I'll add comments in to indicate where the methods end. And of course, as always, I'll have to do a little bit of cleanup work. So there we go. First, we might want to think about what the body of one of these would look like. Now, we could use an if statement like we did previously, but that will only let the user enter the data once. We'd like the user to be able to enter the data as many times as they continue to make mistakes. So what we want is a loop. So let's start with an integer value, which I'll call result. Now I'm going to set it to -1 to start with. The reason is we're going to want to get into the loop at the beginning so that we make sure the value is set at least once. So while result is less than 0. Once again, this is a good time to pause and think about whether we're doing the right thing. So if result is less than 0, we want to go through the loop. Well, let's think about whether that should be less than or equal to. If the result was equal to 0, we would in fact want to get the data because we're trying to get a positive integer, not a non-negative integer. So this in fact should be less than or equal to, not just less than. And here's the body of our loop. So once we're in the loop, we're going to get one piece of data from the scanner. So that will be result equals input.nextInt. Now, if somebody happens to enter a negative value, they need to get some feedback on that. So we're going to put in an if statement that will give them that feedback. If result is less than or equal to 0, less than or equal to, not less than, because the boundary condition of being equal to 0 is not acceptable data. We'll do system out println. Please please enter a positive value. And of course, at the end of the method, we're going to return the result. So let's step through that method once and make sure it will work before we run it. So result is initially -1. Result less than or equal to 0 would be true, so we get into the loop. That's very important because we want to make sure we let the user enter the data at least once. So let's say our user enters -3 at the input.nextInt on line 116. Result less than or equal to 0 would be true. So then the printout would say, please enter a positive value, which is good feedback. Result would be -2, which is less than or equal to 0. And so the user would get another opportunity to re-enter the data. Let's suppose the second time they enter 3. Well, result less than or equal to 0 would be false then. So the system out println statement on line 119 would not be done, and the loop would exit. We would then return result. So that looks good. We could copy and paste this into get positive double and make a few cosmetic changes, but rather than doing that right now, let's actually test it first to make sure it's working. we have a place in the code where we've done something like this, and so we can replace that with this method. So here we go. Up above our while loop, remember when we were entering the total number of talk minutes? All this can now be replaced by our one method call. So we'll say talk minutes equals get positive int, and it needed a scanner parameter. We called scanner keyboard here, or I think we did. Yeah, we called it keyboard. So now we need to figure out why Eclipse isn't happy. So let's look at the little red X. It's undefined for this type. Well, what could have happened? Let's go down and take a look at the method we just wrote. Ah, I see what the problem is on line 103. Notice that I misspelled the word positive. I've been forgetting that I lately. We definitely need to have that in there. And you'll notice that our little red X's disappeared from our boundaries, so that's a sign that we fixed this successfully. Notice that our code got shorter when we entered the method, so that's a good thing. Now let's run the method and see if it's doing what it's supposed to do. Enter the number of minutes you talk each month, 500. Enter your plan name or end to get results, so that's working correctly. It's important not just to check the error cases, but to check the regular ones too. Now let's try an error case. Enter the number of minutes you talk. Let's say I talked -10 minutes. Please enter a positive value. There's -3. Please enter a positive value. -5. Maybe it's time for me to get a clue. Enter your plan name. So that seems to be working very nicely at this point. Now there is one case we didn't test that we probably should, and that's the boundary case, the one at 0. So let's run that test too. So if we entered 0, it says please enter a positive value. If we enter 1, it's perfectly happy. Now there's no reason to run the program any further because we've just tested the piece of code that we finished writing. Now that that code has been tested and we think that it's working correctly, it makes sense to cut and paste it to the other method. Notice you always want to test before you do that. Now we're going to have to modify it a little bit, of course. For example, our result will be a double, not an int. Now it's not necessary to change that to a -1.0 because Java would promote it, but it is nicer to communicate correctly that that is a double. All these comparisons are exactly the same, and returning result is exactly the same. So we really got that method pretty cheaply. Now let's go back to our code and integrate the methods in the plan. So there's no real error that can happen with the plan name. This is on line 34 of the code. For the monthly cost in pennies, notice what we're going to do is to replace this next double with get positive double of keyboard. Now, I see we have another error from Eclipse again. My guess is that's going to be another missing I, and it is. So let's fix the method name. Now you might want to think for a minute about this next line statement. Does it still belong there or not? Well, it does still belong there because that's an extra new line that gets left over after the last double is read. So we don't want to erase that. We might want to think about whether we want to put that into the method or not. Sometimes it would make sense and sometimes it wouldn't. So we do not want to put that into the method. So here we will change this to get positive int of keyboard. And this one we will change to get positive int of keyboard. Now you'll notice our code didn't necessarily get any shorter here, but our code did get better because now we're doing error checking on every single one of these values. And so that's a step forward. It's not just about having short code, it's about having good code. Now, because we primed our input, we're going to need to do this twice. So the next line for the keyboard, which is leading to the plan name, that one's fine as is. This one should be changed to get positive double of keyboard. This should be changed to get positive int of keyboard. And this one should be changed to get positive double of keyboard. So now we've done that with all of our lines. That's really nice. Our program has actually improved quite a bit because we've increased the amount of error checking without adding many lines of code. So we've reused these methods several times in the code. That's a good thing. Reusing code is exactly what methods are about. Remember, the arguments are the ones that are in the program that calls the method, and the parameters are the ones that are in the method, the ones that get called. The value of the arguments are always patched to the matching parameters. Now, one thing we might want to consider is why don't arguments have types? So let's go back to our code. For example, why didn't I have to put, this is on line 88, scanner keyboard? We're in the main program now, and Java knows that the keyboard is a scanner. We've declared it above. Not only is scanner not helpful here, it's actually not even permitted to be here. So the keyboard that's in line 88 is an argument. It doesn't have a type. Now let's compare that to what happens down here on line 103 when we're looking at the parameter. So scanner input is the parameter. Suppose we didn't have scanner in front of this. There's no way for Java to know that scanner was the correct type. Input could be an int, it could be a double, it could be something else we've never heard of. So parameters have to have types and arguments don't. This takes a little bit of practice too. Now, another question that people sometimes ask is, do the argument and parameter names have to match? No, they don't. And in fact, if they did have to match, it would really be unfortunate because it would mean that parameters would be absolutely useless. So we can call them anything they want. What is important is that they have meaning in the context that you're using them. Now, do the argument and parameter types have to match? Yes, they do. There's one exception to that rule, though, and that's that if a type can be promoted. So, for example, if you pass in an integer argument to a double parameter, because an integer can be promoted to a double, that does work. But in this case, we have scanners, and nothing gets promoted to a scanner. Let's go back to our program and run it and make sure it's working at this point. Anytime you make changes, you always want to test it thoroughly. I'm going to sometimes shortcut the testing just to save us some time here, but testing code is extremely important, so don't shortcut it when you're working on it. So we talk 500 minutes. Now this part we've tested before. Now that's interesting. Look what happened there. I entered 500 and then it said enter your plan name or N, and it went on. We probably know what that means. It looks to me like I might have erased a readline statement that I didn't mean to. So let's go and take a look at this. Now this is the one that's before the loop, so we know where that is. So here we go. Enter the number of minutes you talk each month. And notice I did, in fact, erase that read line. So we need to fix that now. There we go. Keyboard.next line will erase the new line character at the end of the line. So I'll re-enter 500 minutes. That looks better. Plan 1. Our monthly cost was $19.99. Oh my goodness, look at what we have here. Enter the monthly cost, and it says an input mismatch exception. The trick to doing these things is all of these are in the scanner. So what you want to spot is the highest one on the list that comes from your code. So in this case, that's cell phone iteration 6, line 124. If you click on this in Eclipse, it will take you right to that line. So look what happened here. When we cut and pasted our code from getPositiveInt into getPositiveDouble, we forgot to fix the method name. We don't want nextInt, what we want is nextDouble. Well, that's looking better. Let's run the program again. Incidentally, problems like that are very common with copy and paste. So common you may want to think about whether that's a good strategy to use in programs. So 500 minutes, plan 1, monthly cost, $19.99, the plan minutes, 100, the additional minute cost, 0.05. And we've got another problem there. So I'm using the same strategy again. I'm going down to the first one that's in my code, which is this one on line 109, and clicking on it. Now in this case it says nextInt. Well, that's the correct thing. So maybe the problem is in where we called it. So this is the additional minute cost. Right up in here. And we can see that what we did was we called the wrong method. This should have been a double. We could fix that one problem and move on, but that is the kind of mistake that I might have made twice. So let's actually check our second input. So notice the second time around I got it right. I put in getPositiveDouble. Let's run the program again. $500 minutes, plan 1, $19.99, enter the plan minutes. That could be 100, the additional minute cost. So the first thing I did was check that the standard input was working correctly, things that were all legal. Now when we enter plan 2, let's see what happens with negative data. So let's say we charge negative $200 a month. It says, please enter a positive value. So in this case, it looks like it's working just fine. Now let's check the plan minutes. And that's also catching the error of being too low. Let's even try 0 on this one. That's looking good too. Enter the additional minute cost. Please enter a positive value. Please enter a positive value. All this is looking very good. And the total cost for plan 2. So right now it looks like all of our input is working well. So we've successfully integrated methods into this program. Now let's design another signature and integrate another method. The calculation of costs could also be in a method. So the method name could be find plan cost in pennies. The inputs, which would be the parameters, would be our monthly cost in pennies, our monthly minutes, our extra minute cost in pennies, and the number of minutes that are talked. So those are the basic pieces that we would need to construct this. And the return type would be an int. Now the reason it's an int instead of a double is because we're finding the cost in pennies. And of course the method should still be public and static. So let's go and implement the method and call it. And of course we'll have to test our program again. You can put this method anywhere you'd like. You can put it before the main program or after it, or before or after getPositiveInt. I'm choosing to put it between the main program and getPositiveInt because that's a convenient place for me to find it. So it's public static int get plan cost in pennies. Now in this case, we're taking a calculation that we know is working and we want to bring it in. Here's the calculation. Right there. So I'm going to cut that. If you're a more cautious sort, you might want to copy instead of cutting. And I'm going to bring that code down here. Now, our total cost in pennies is our output. So we're going to want to have a local variable for that, which is what's on line 92. So we'll need int talk minutes, int plan minutes, int monthly cost pennies, and int additional minutes pennies. So you've probably been watching Eclipse getting less and less frustrated with me as I've entered more and more data. Here we're going to return the total cost in pennies. And let's see what Eclipse is unhappy about. Insert a semicolon. Well, it does have a point there. Okay, so now that our method is written, we can go call it in the code. Now what I'm going to do is I'm going to copy it from here, mostly so that I get all the parameters in the right order. Now I'm going to have to modify them to make them arguments. So here's where it goes. We're still going to need to declare an int, total cost in pennies. And then we'll say that total cost in pennies equals get plan cost. Now remember, we took these variables exactly, and so we know we can reuse them. But because these are arguments, not parameters, they don't have the types in front of them. So I'm removing the types. And that got rid of a lot of bad stuff very fast. Of course, we need a semicolon after it, as we do at the end of all lines in Java. And so that method's looking better. Notice that our while statement got quite a bit shorter here, so that's a good thing. Let's run our code again. So 500 minutes, plan 1, 1999 for 100 minutes, 5 cents. Let's enter plan 2 for $29.99 for 101 minutes and 7 cents. And then enter end to end the program. And it says the cheapest plan was plan 1, which we know to be correct. Now we could test our program more fully, and in fact we should test our program more fully. How do you know when to stop making methods? Well, in general, one-line methods aren't used. There are some exceptions, and you're even going to see some of these exceptions before too long. In general, good main programs tend to be about 10 to 30 lines long. Now, it's not always possible or wise to reach this goal. For example, in this particular case, we could take our whole sentinel loop and put it into a method, but would that really make our program easier to understand? Basically, then our main program disappears and the other method would get very long. And so that doesn't really make anything any better. So there's no reason to do that. So you don't put things in methods just for the fun of it. Well, unless, if you're having a good time, it's okay. But in general, it's not done for programming. In general, beginning programmers tend to make too few methods, and they tend to make methods too long. I think this is because of parameter passing anxiety, and parameter passing is a little bit uncomfortable at first. Keep practicing it, though, and you'll get better at it. And remember, keep programming.